In section 9.3, we talk about what happens at a molecular level when a solution forms. And what occurs is different depending on whether our solute is an ionic compound or whether it is a covalent compound. When an ionic compound dissolves in water, the crystalline ionic compound is dissociated into its component ions. The negative end of our water molecules will be attracted to the positive end of the positive ions on the surface of the crystal and will pull those crystals out of the crystal. Similarly, the positive ends of our water molecules will be attracted to the negative ions and will pull those guys off the surface of the crystal. So in the solid crystal, all of the ions are held rigidly in place, but when the ionic compound is dissolved in water, the ions are floating around independent of each other. Now, why does this happen? Well, this happens because the attractive forces between the water molecules and the ions are greater than the forces between the oppositely charged ions in the crystal, so the water molecules are able to overcome the forces that hold the ions into the crystal. So this is interesting, and it can be proven by considering an aqueous solution of sodium chloride and how it conducts electricity. So if I have a sample of distilled water, there are no charged particles present in distilled water, and the solution will, or the sample of pure water, will not conduct. If I have a sample of crystalline sodium chloride, all of the particles are locked in place and unable to move. As electricity is the movement of charged particles, a solid sample of sodium chloride won't conduct. However, if I pour the salt into the water and give it a stir, I generate an aqueous solution of sodium chloride and I find that it conducts. This means that there must be mobile charged particles because, well, electricity is the movement of charged particles. This tells me that in the aqueous solution of sodium chloride, the sodium ions and the chloride ions are able to move around independent of each other. So our model for dissolution of ionic compounds must be correct. Some, but not all, covalent compounds are soluble in water. A good example of that is ethanol, the kind of alcohol that gets you drunk. Most of these substances do not dissociate into ions, but remain intact as neutral molecules. Aqueous solutions of covalent molecules that do not conduct electricity are called non-electrolytes, as opposed to aqueous solution of ionic compounds which do conduct electricity, which are referred to as electrolytes. And that concludes our video for section 9.3.